All right, let's see here. Oh, excellent connection. I don't believe that for a second. All right, hello everyone. We are going to do a live stream tonight on designing a open source escape room gadget, specifically an RFID reader puzzle. And I am just checking to make sure that you're actually hearing me, because it'd be really embarrassing to record this and not have any audio. Okay, it looks like we're autoing. Alright, if not, I'll be recording this again. This will be a good practice. Bum, bum, bum. Alright, so anyway, let's see, what can we see? Blah, 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 blah. So over here, ooh, which way is it? To screen. I've got the Arduino IDE. I usually code in Visual Studio Code, or at least I have been trying here recently to do so. But for the purposes of, I think, it's a little noisy, and so therefore to do just a demo and explaining how you can do this I'm just doing it in the Arduino IDE. I think today 1.8.10 dropped, so you can download the latest and greatest if you've got it, and you download, you just run the executable, and it will prompt you to uninstall your original version, or whatever version you have running right now, and it'll go ahead and install the new one. I don't think anything really major dropped in this new release, so necessarily it's not like a must download. All right, I'm just trying to get a file opened up too here. Okay, so I talked about it on our last episode of Gears of Resistance that I'm working on a series of tutorial or projects that's going to be a combination of a free GitHub repository where it's going to contain all the software, hardware, so a circuit board and the any sort of mechanical, be it an enclosure or any sort of mechanical parts for open source for escape room gadgets. So let me back up real quick. This summer did a crap ton of escape rooms, and in doing a lot of the escape rooms as a nerd, you start looking around and you start noticing things like, oh look, there's a Raspberry Pi in there, or look, there's an Arduino in there, or there's some sort of embedded electronics. So it was kind of interesting to me to see, and there was two different styles. So I noticed that there are a few companies, I guess, that are making kind of like premium grade gadgets, or kind of more plug and play gadgets. For kind of like the higher end escape rooms, that ones that are kind of like franchise based, but played a lot of mom and pop shop ones too. And I think the cool thing about that one is, well, at least what I've noticed in the ones that I played, if you go to one that's a franchise based, you're going to kind of play the same escape rooms wherever you go. So if you're in New York, and you play one of these, commercial outfits that do escape rooms, and you come down to DC, chances are you're going to find the same exact escape room, or at least the very same puzzles. It's kind of like cookie cutter. Here's what you buy a plan, and I think that's great. But I think two things. Down here in Southern Maryland, where we don't have that kind of, we don't have enough crowd to warrant those kind of larger ones, we got two homegrown ones, and the one really is cool because it takes some local legends. St. Mary's County, where we're at, it was, I think, like, it's the original landing in Maryland, like 1630s, I think. Our settlers came here, and of course, so we're kind of like the tail end of like the whole Salem witch hunt, and so witches were a big thing. There was a lady down here, her name was Maul Dyer. She was accused of a witch, and so basically they took her story and incorporated it into an escape room, and it was really cool. The one thing we noticed about it, though, is that the smaller escape rooms, you can kind of tell things are kind of like put together people that have some skills, tech skills, put those together. And we were just thinking maybe there's a way to bridge these two and kind of do come up with some standard open source designs for various gadgets that other people you could either take and just use as is, if you've got some skills, you could tweak and modify for your needs. So trying to work those two angles. Or I've even heard of people making the escape rooms in their own house. Some people that, I guess, if they've got a spare room, they've been actually turning those into escape rooms for their friends and family to enjoy. So we're going to take a stab at coming up with some designs. We're going to open source all the designs and put them on our GitHub. You can, if you know what you're doing, you can just take it, go do whatever you want. On the flip side, if you need maybe a little help, a little understanding, or you need if you want to tweak it and you don't really understand what you're doing, we're going to sell for like a nominal fee, like $4 or $5, a guidebook that's going to go with it, so that you can understand how it works, how the design, what pins do what are the name of the signals, what are the name of the variables in the software, so that you can tweak things. That way, we can honor both. The design, in keeping with the open source spirit, that'll be free. To get a little bit of help, support, that'll be the paid model, and it'll be, again, $3 or $4, and we'll send like a PDF or something that is well written, and we'll step you through the hardware and the software. So with that, let's grab into where we're at right now. So we are using the Arduino Uno, and we are designing a shield to go with the Uno, and we're doing some custom firmware. The first one is going to be an RFID based one. So basically, if you've ever gone into a room where you have to like grab 2 or 3 or 4 different things and stick it at a certain spot, and when you do so, it kind of opens a latch, and like either a door pops open or something, a latch gets unlocked in a treasure box. There's a couple ways to do that, and the one I think I've seen a lot is if you look in there, people kind of embed an RFID tag in the objects, and then at the location that you're supposed to group them all together, that's where the RFID readers are, because the things that are being moved, those are mobile. There's no wires, so those are where the tags go, the objects, and then again, the electronics are stationary at either like a desk or a mantelpiece or something like that. So we are going to do basically a design that's going to be customizable to a degree. You can go from anywhere from 1 to 4 RFID readers, and we are going to give different types of outputs. So we're going to give like an active low. So we'll give a active low and an active high. So depending on what outputs you want to drive. So basically, when the system is locked, we'll have one signal that's high, one that's low, and then when the players have put all the right pieces in the right place, we'll switch it, and we'll have an active low and an active high output. So again, depending on what you interface with, and then we're going to do an analog output that you can control and set in the code as well. So giving you some options, and that's where the code will come into play and the user guide will come into play. You can take our stuff and tweak it to meet your own needs. The idea is not to build a final product. It's to give you 80% of a final product that then you can tweak the last 20% to meet your needs for whatever kind of work you want to make. For some people that'll be great. For some people that won't be great. So just caveat again, people that this is kind of geared to is people that have at least an interest in tinkering a little bit. It's not going to be a commercial off the shelf plug and play solution. That is not the goal. So let's go ahead and kind of also want to use this as an opportunity to kind of talk about like our workflow here, and kind of it's a lot of our work is kind of rapid prototyping. So people come to us, and within a few weeks we turn around some sort of workable prototype, both in form and function. So we kind of give them thoughts on what it will look like given the constraints of the parts. and then meet most of the functionality, or at least enough of functionality to get some feedback from end users. So let's go ahead and let's zoom this back out. So my workflow is kind of I use Autodesk Sketchbook to, let's see, so Sketchbook to do some doodles, and that's not the doodle I've been using. Let me drop this over here real quick. So this is what the user guide's going to look like. Right now, this is not what it's going to look like. This is just kind of like placeholders. We'll make it look prettier and all that. But for now, just to get an idea. So what I like to do is, here we go. I like to doodle and sketch, kind of my thoughts. So here, my thinking was I'm going to have the Arduino Uno. I'm going to put a shield on top of that. I want to use screw terminals because maker spaces, or excuse me, escape rooms, sometimes people can get a little rambunctious. They get a little, what's the word I'm looking for? Physical with whatever they think is a clue. So want to give it some mechanical rigidity and some resilience. So instead of just using like hookup wires and going right into headers, use some screw terminals. And I'm also thinking about mobility, the fact that someone might put the brains at one part, but they want to put the NFC, the RFID readers in different places. So we're thinking about, again, having like a board where all you can have your RFID, and we're using, by the way, I should throw that out here real quick, PN532s. Let me look at the code again real quick. Yeah, PN532 RFID readers. We had started with another reader called the RC522, and we were having issues with, so they were both SPI, well, I guess they both have I2C and SPI, but we only had SPI libraries available. And again, in the world of rapid prototyping, you don't always have the time to write everything custom. So as much code that you can kludge together that's already written, that's just if you're looking at it from a final design, yeah, it's not always the most desirable. But from a reality of prototyping and just getting something out quick, we're talking a few weeks at most. It's acceptable. It really is, because a lot of times, at this point, you're more proof of concept. Does the idea work? So anyway, so we grabbed a couple of these boards off of Amazon. I think Adafruit also does some readers based on this chipset, so we were able to use their libraries. Again, talking over SPI, and back to my original point, the 522, we were having an issue where, and we think it's with the library, basically there is a master out, slave in, a master in, slave out. So basically the microcontroller talks to the device, and the device talks back to the microcontroller. Then there's the clocks, and then there is kind of what's called a, they think it's called slave select. I keep thinking chip select, because I'm a chip guy, but basically 3 of the wires are common to every board you go to. So if you have 4 RFID readers, so like if I had 4 of these here, 3 of the wires would be the same. MISO, MOSI, master in, slave out, master out, slave in, and the clock are all the same. Then each individual RFID reader would have to have a slave select line. And for whatever reason, the library worked great for one board, but 2, 3, 4, and 2 kind of worked intermittently. 3 never worked at all. So we switched over to these PN532 boards. The nice thing is they are still SPI communications, and so we didn't have to make any real changes to the board, but they do work with multiple readers, so that's great. So again, these boards here, let me zoom in if I can zoom in a little bit. Come on. Come on. Nope, too far. There we go. Dang it. Very. There we go. All right. So we're going to get these boards commercially available. The Uno commercially available. We're going to make our own custom shield, the own custom board for all the different RFID readers to tag into, and then all those go back to the Uno and the shield. And then we want to have another board for controlling for the outputs. So the red, green little LEDs there represent the outputs. When the box is locked, one will be lit, the other one will be dark, and then when the box is open, it'll reverse. And if you don't want to use it with LEDs, if you want to use something else, you can use them just as however you want. It'll be a 5-volt signal, and then a pulse width modulated for an analog output too. The other note is the different RFID readers, and I'm not sure. We're trying to make it so that you don't have to necessarily use the 532. You could use another board if you want it. But one of the differences, some of them are 3 volts, some of them are 5 volts. So we're going to put a. Actually, let's go back. We're done with this. So this whole point was, first thing I always do is kind of just doodle out ideas for what I think I'm going to be building. That's the first step in my process usually. So talk with the customer, back and forth, get some ideas, take some notes, and then doodle as much as I can get, as fast as I can get to doodling out the ideas. The happier and usually the better I am. If I get enough information where I can doodle out an idea, it's for me. And then I feel like I understand the requirements enough. And doodling helps me question where I don't know things and go back to the client and hey, fill in these blanks for me. So anyway, we're going to go ahead and put in a jumper, a male header here, so that you can have a jumper to either switch between 3 volt or 5 volt to the RFID mating board, or whatever I will call it. That way you can power 5 volt or 3 volt RFID readers. So, real quick, I guess, then we'll start with the layout of the up here. So this is the board for the Arduino Shield. Obviously, there's some constraints, and that's the other thing about design is sometimes you're constrained in the form factor of the Uno. There's a restraining factor. I have to, make it made up. I have to have these male headers. And if I want to mount it, these mounting holes have to be at the same spot. So, nice thing again with Eagle and KiCad or KiCad or however you want to say it. There are plenty of standard libraries now with parts, and that gives you a starting box. So we basically grabbed an Arduino Uno and started that. That gave us our again, in the schematic, it looks like a block, and then over on the board editor, you actually get what looks like an Uno shield. So, we're basically going to have on the left side here is everything that talks to the RFID readers. So there's going to be a serial clock, meso, MOSI, and a reset, which we're not using, but we're going to go ahead and wire it out in case we need it in the future. So those are the 4 common that go to all RFID readers. Everyone will get to see the same signal. And then we have the 4 chips or slave selects. I keep calling them chip selects because that's just the world I grew up in. Each one of these will go to a unique RFID reader. And they need at least the clock, the meso, the MOSI, and the RFID chip select or slave select. Each board has those 4 signals. And then again, over here, we're going to route out 5 volts and 3 volts, and then we'll put that onto where you can change a jumper And then power and grounds, we're using a ground plane. That's why you don't see the ground signal actually routed here. It's actually, we drew the polygon and made that the ground plane, and so anywhere there's ground, I don't have to run I don't have to run a signal trace. It's just going to tap into the ground plane and be done. Then over here we're going to have a this is the output actuator. So there's again ground, 5 volts for power in case whatever if you've got to power something. And then the open LED, a pulse width module, the analog output, and then a closed LED. So when it's locked or open, when it's locked or closed, this wire will be high, this line will be high, and this will be closed. And then when it opens, this goes high and this goes low. And you could, use those in reverse if you had. This is basically built on the idea of active high, but using them in reverse, you could use it as active low. And then the analog, you can set that in the code. And then we also made it, we're going to break out the reset pin. That way, at the end of, after someone plays the game and they're done, and the person that, folks that are running the escape room have to go back in and reset it, instead of taking apart whatever this thing is incorporated into, we'll wire out a reset button that someone can then reset the system without too much heartache. Though I realize, though, with the escape room, sometimes, if you put something behind a box or a lock, and that just is something that people that must be a part of the escape room. But anyway, we'll at least put it there as a possible way of resetting it once the room is over, or once whatever round of the game is over, and you've got to set it up for the room for the next team to come through. That's what the reset is for. It's basically to reset for the operators of the escape room to have a quick and easy way to reset the system. That's a lot of words to say something simple. And then that's all that's to it. The nice thing is that this board is not necessarily tied to the RFID readers. It's tied to anything that uses SPI. So this is kind of like the SPI board is what I would call it. I'll probably do another one for I2C devices, and then for things that are just digital and analog. So we might end up with having like 3 different shields. And then, again, the reason I like using EagleCAD, or just I think it's just called Eagle now these days, I can export a 3D out into Fusion 360, and if I went to build a box to enclose this in, I could grab a model of the Uno, I could throw in some headers, mate that into the Uno, and get the idea of how big this board is going to be, how thick and wide and tall, and then I could start designing a like an enclosure around that, which I will do eventually. And just so for completeness' sake, so folks just know some again of the workflow for me when I'm looking at parts. 2 things. Octopart. If you've never used Octopart, they have a common parts library. So if you're looking at, like, if you're not inventing the next iPhone, chances are you're going to be using parts that are kind of commercially available, and you want cheap part, you want the most inexpensive part. I won't say cheap. You want inexpensive parts. You want good parts, but you want them inexpensive. And that really comes down to know is, the most used parts are going to they're going to be created in bigger numbers, which means they're going to be more less expensive. But it's something, if you've ever gone to like Mouser or DigiKey or Jamico, and you sit there and you search, like, you put in resistor. I want a 10 kilo ohm resistor. Just how many freaking choices there are. So the common parts library is a great resource for just going in there and figuring out for either production or prototyping. Let me go back, like LEDs. Like, what are like the most common LEDs? Or let's go down to the resistors. There's a lot of, yeah, so resistors, right? Like, which, of the 18 trillion choices that Mauser presents me, what can I realistically, what can I realistically get my hands on, and what also can I get at a fair and reasonable rate, especially considering the fact that, people that are going to be using these design files that we're creating aren't going to be turning these out in huge batches. You're going to be making these in small batches, which means you're really not going to get the economies of scale savings. So you want to make sure your parts as inexpensive as possible. So Octopart for that. The other thing I do is, let's see here, for 3D parts library, because a lot of times Eagle doesn't have or this is still kind of new. Like, it's good for footprints, but 3D models is kind of not there yet. So there are resources to grab those STL files, or as step files. I think they use step files. And so library.io, not libraries. Libraries.io, by the way, is good for looking for software libraries. Library.io's Autodesk's kind of, I would say, kind of like they're using it kind of like their GitHub for like doing design. The part of the, again, we talked about like earlier on the podcast, the collaboration, parts library collaboration, and library.io is kind of like the hub, for lack of a better term. Let me boom, 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 boom. Come on. There we go. So they have a really great package create, like a tool to make packages for if you have a part and it doesn't have a package to it. So you can go in and pick, I need do a QFN, or DFN. You can customize, you go find the parts, you look at the data sheet, get the physical, and then you have the ability to really quickly take that and then export it into EagleCAD, and then have EagleCAD kick it over to Fusion to make your 3D model. What was the other resource? And if this doesn't work, or if you're like, because I don't think they have like quite like every, like they start with this generic library of parts, and then you can kind of customize it. But if you still can't find something, or if you're looking for more like mechanical parts, let me see here. Not FreeCAD. It is GrabCAD. Let me bring this over here. So another resource, library.o, grabcad.com. Let me see here. Let me log in. Boom, 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 boom. Come on. Yeah. So, boom, 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 boom. Let's say screw terminals. That's always one that, for whatever reason, while very common parts, for some reason it's hard to get 3D models. So, depending, so here's 3.5 millimeter or 5 millimeter. I think we're using 3.5 millimeter. So here you have screw terminals. So you've got the 4 terminal, 2 terminal, 5 terminal. So each one is its own design file, and then the same thing. You can go up here and download all the files. I think it's STP files, and then you go into your schematic, you right click your part in Eagle, and then you'll see a place where it says, import a 3D file for this if it doesn't already have one. And now that translates down to your floor plan, or excuse me, your board layout, and then again into Fusion 360. So check those out if you're interested. That's kind of my physical design. And then again, let's talk about the code. Let's talk about the code a little bit. So my work process is to kind of code a little bit, do a little board layout, but I would say most of the time I start with some code, only because I'm probably using a predefined, I'm going to use some sort of development board at first, usually always. Again, the prototyping world, I'm not going to be making complete custom solutions if I can avoid it at all costs. I want to use as much commercially available off the shelf because it's time is more important in the prototyping phase than cost or kind of like the sexy design, making it look pretty. It's not really the point at this point. So again, so we'll go over to software. Usually I'll use, like I said, I prefer coding now. In Visual Code Studio, I used Atmel Studio because a lot of my stuff, my history has been with AVRs, and I think now that basically PIC and AVR, that world is combining since the merger. Atmel buying out, so I like the idea of having the ability to do the debugging with a hardware debugger. But I think again, we make, as professionals, kind of poo-pooed Arduino, but really Arduinos and other open source alternatives to those, be it the what's another popular one I like to use, the Particle.io. A lot of these boards, they're while they may have the stigma of being maker, they're really they're the performance-wise they're professional grade. The tools quite aren't there yet, but a lot of that is changing. The tools are getting more powerful, and if debuggers are your only hang up, I think this is going to be the year that kind of changes, as Arduino's made a lot of, and it's going to make a lot of changes to make things more robust for professionals, I would say. Anyways, but again, as I said earlier, I'm using the Arduino IDE as is, just because it's there's less noise for the purposes of demonstrating this. So, some things to notice: always document. Try to honor if you're using someone else's code. So in this case, we're leveraging Adafruit's PN. That's kind of like the starting block. We went with their libraries for the PN532 RFID reader. So we're giving them their shout out here that we're building this on top of theirs, and we're honoring all the licensing. So first things, we're going to walk through. This is going to be meant for people that either very limited coding and want to look at maybe some advanced concepts, not advanced, let's say intermediate concepts. I don't think I'm an advanced guy. And we'll just talk about, how to make code as compact as possible for someone who's, again, I'm not as an all-star programmer. It's in fact been many years since I really have done it full time. It's most of my world now. I'd say most of my time is split. Software development, hardware development is 25 each, and then all the stuff of either testing and all the other business kind of functions. It's up the other half of my time. So always start off. I always put all my libraries that I'm including up front. I use my debug messaging. So I say this is a way to basically make it real easy to turn on and off whether I want to have waste time with serial using my serial port for messaging. So obviously, when this is all said and done, there's probably not going to be a computer running. This is going to be running in an escape room where there is no computer monitor. It's just going to be the RFID readers. So there's no sense wasting clock cycles doing serial print statements when you don't have to. So what I can do here, I do pound define debug. If I want to if I go to the final, I'm ready to go for production, I'll just comment this out. Now debug is not defined. This code won't run. I won't get serial prints. And so I make one for both serial print and serial print line. So I can either print a bunch of things on one line or print new lines. So that's all this does. This is basically, you're going to notice down here I don't have serial print. I have my debug prints. So debug print, debug print, debug print. That's one thing that maybe, I don't know, you may have stumbled upon, or if you you do this professionally, you probably even know a better way to do this than I do. That's how I do it. All right. Constant unsigned integer 32. So, you could do just int. This basically, my understanding, what I do is this makes your code more portable because an int on a 32-bit microcontroller is different than an int on an 8-bit, or whatever architecture you're moving around to. This kind of just, instead of just relying on hope and prayer kind of thing, we're very being explicit in what we're defining. So const means it's not really a variable. It's more of it's a constant. So this cannot get changed during execution, as opposed to static, which is basically if I declare this variable as it moves, as it gets passed around or gets used, say in a function call, whatever happens to that variable, when I come back to that function call later, I'll still have that value is static. It doesn't get erased each time. It stays and remains, and so that's kind of the difference between const and static in a real nutshell. I don't think I have anything static here. It's all just const. So, and if you're actually looking at this because you've downloaded my code and you're using it, this is where you're going to change. It's right now it's line 46, but it might change as I make tweaks to this code. But num underscore readers, change that. If you've got one reader, if you've got 3 readers, this becomes 3. And so right here, I think my cat is behind me. So that's your first thing to change. However many RFID readers you want to use, you change that number there. That's another thing. So for me, for constants, things that are either macros, I treat this kind of like the idea of a macro, the debug statement, and then my constants, I always do all uppercase and then underscore between the words. That lets me know that this is something that's constant, will not change. So then I have all my pin assignments next. I always try to group those, and I try to do those in numerical descending order. So I'm saying here the serial clock is going to be a pin 13, the meso pin is 12, Mosey pin is 11, and then each of my chip selects or slave selects pins are here, and then my output pins. And I always use the word pin, just again a force a habit kind of thing. I know it's not a value. I know it's tied to a physical chip. And what else do we have? Let's see here. Then the tag ID. So this is where the tags that I'm going to accept. I get the this is the decimal of the. So usually if you use your phone with an NFC reader, you'll get a hex. You got to convert that hex to a decimal, and put that there. And again, if you're going to use 3 tag readers or 4 tag readers, uncomment these 2 lines. And put in the tags that are the one you want to accept for each reader. That's the other important thing. Label your readers so that you know that tag reader 1, 2, 3, 4 physically. So that way, as you're setting up your escape room, you'll remember which tag reader goes where. And if you have to troubleshoot, you can go. You'll look. So I always write tag ID, and I wrote the tag ID on the physical reader itself. Okay. Next, moving on. What value do I want? The output on the pulse, the analog output, the PWM, when it's low, when it's high. So basically 0 and 5 volts. But you can tweak these however you want. When I use delays, I put a delay amount of 1 second. I start the system off. This is not a complicated state machine. It's either locked or unlocked, but to track where I'm starting off, my system starts off locked. Here I have an array of all my slave select pins. You'll see why we make it an array here in a little bit. It makes coding a lot easier and cleaner. And then an array of the accepted tags. So basically what I'm saying is, give me an array of integers, 32-bit integers, slave select, and that's the name of the variable, and initialize it with, and you'll notice that these here are what I constantly define up here. So, make me, so it's basically, and the size of num readers. So up here I said, so make me an array of size 2, and initialize the zeroth place and the first place with these two tag IDs, or the pin. This is case it's the name of where the pins are for the slave selects. Down here, same concept, an array of accepted tags, and initialize with tag ID 1 and tag ID 2. You'll see why we make it an array in a little bit, and then we're going to make an array of pointers. That's what this little stars means. So if you don't know what pointers are, we're not going to get to that right now. But basically I'm saying I'm going to make an array of size 2, again, num readers, the number of readers I have. And I'm going to have an array that points to different NFC readers, because I'm going to have to initialize an instance of the Adafruit library for every RFID reader I have, basically. All right. Hopefully that makes sense. Let's jump into the setup. I start off, let's turn on my serial, debug, statement, welcome to the room, just so you know I'm working. While start with this little setup loop is basically going to initialize. Remember we created this array to NFC. We created an array of a pointer array where we're going to declare new instances of the Adafruit PN532 library using these pins. And if you notice, SS pin, open bracket, X, basically I can now walk through and create a new instance of the Adafruit PN532 library for every RFID reader I have, and I don't have to change the code. The only thing I have to change is the num readers. And whether so if you as the end user decide to make this 4 readers long or 3 readers long, I don't have to rewrite the code. So this is a way to create a variable amount of RFID readers based on your use case, whatever your needs are. And then to call and to start. This is basically, instead of you know how like you would do the dot notation. So because NFC readers is an array of pointers, I have to use the arrow notation. So declare the function to use the begin function, instead of NFC readers dot begin, I do NFC readers arrow begin. And again, the arrays allow me to have a way to make this a variable amount of readers. If you only have 1 reader or 4 readers, the code is the same. With that, I'm going to pause there. This is going to end this video, and we're going to pick up the code on the next stream. So for that, thanks for listening and watching. Check us out on gearsofresistance.com. Till next time, stay quirky, keep it steamy, and make better always.